Hi everyone, we're going to be doing a lab today about the specific heat capacity of unknown metals using calorimetry technique. And I'm wearing our periodic table chart for today. So a few things that you're going to need. Make sure that you have already previewed on the Google Classroom so you can download the PDF or the Word doc version of our lab report. It's fairly short, and I'll go through the procedure as quickly as possible. This time around, instead of testing, so there's quite a few changes in the procedure. I had to modify it since I'm using the kitchen as opposed to our lab. We're going to be testing only two different metals rather than multiple metals. So I'll try to go through the whole procedure. Your job is to make sure that you collect all the data and that you be observant and apply this to the idea that when you are heating a substance, it's the formula we talked about. Q is equal to Sm delta T. Sometimes it's written, I think on our lab it's written as MC delta T. The C and S is exactly the same. It signifies specific heat capacity. One thing to note is that whatever is lost by the system, so whatever we're looking at, must be gained by the surroundings. So that's kind of like a key point there. Whatever energy is being released must be absorbed by the surrounding of environment of that system. So in this case, the system we're focusing on would be the metals, the two unknown metals, and then the surrounding will be the water that's going to be inside the calorimeter. So what we have set materials for today, let me move our camera so you can kind of get a sense of what's available for us. We have our scale. There's also our calorimeter, bomb calorimeter. We're using two styrofoam cups with a cover, and this is like our glass stirring rod to control that, or to stir it. We also have 150 milliliters of water. There's an adjustment in the volume. Our thermometer is connected to our, let me move this closer, you can perhaps see that temperature. This is empty for now. And I just have regular tongs here. We have our thermometer right now is measuring the initial temperature of our water. So the initial temperature, at least for the first metal we're going to test, is 21.2 degrees. And it's been kind of sitting there for a while. I can't show you right now because part of this is the mystery of it. But we do have two metals that are heating up, and I'm going to lower the fire because it's been boiling for a while. So the idea here is that the temperature of those metals must be comparable to the water that it's been boiling at, and it's been there for a good 10 minutes or so, and it's been boiling for a while, so it should be, our starting temperature for those two metals should be 100 degrees Celsius. So those are our initial data, 21.2 degrees Celsius for water that we're going to be using, but the initial temperature for the metals, for metal A, is 100 degrees Celsius. All right, so let's start with, first we had to measure the weight of our calorimeter. So let me remove that. I'm gonna keep the cup cover because we'll do the same at the end. So zero this. It looks like it is 7.54 grams. 7.54 grams. Let me try that again just to verify. Zero. So weird fluctuation there. 7.5, now it's like 7.51. Something changed. We'll go with 7.51, the more recent measurement. All right, so now let me remove that. Again, we have 150 milliliters of water. That's our starting amount. And I'm going to, based on the procedure, we're going to add our water inside our calorimeter. So now I'm going to double our calorimeter setup for insulation. I need place to hold it steady. Close this for now. Place that there. And I'm going to pour our 150 milliliters of water. Put our thermometer in there, make sure it's touching, good. And there's some change in water temperature, something to kind of factor. But we'll start with our initial temperature that we had mentioned earlier. So now what I'm going to do is I'm going to add the metal A, inside our calorimeter, and then there will be a change in temperature. How do we know that we're done recording the temperature if for at least a couple minutes the temperature is no longer changing? So for the first, and every 30 seconds I'll point it out. So we'll set a kind of a timer. I'll just use the clock that I have here. So I'm going to start right now. So I'm going to move our first metal from our, I don't know if you can see it, but let me kind of show you. Right there, so we can get everything in the picture. Okay, here's your first metal. And in a way, I kind of don't want you to see the metal. We'll weigh the metal and kind of describe it later on. But here is our first one. Okay, so I added it in there. So what we'll do is we'll wait for every about 30 seconds. I'm going to add a little bit more water for the second metal here. And then kind of keep that boiling while we're doing the first experiment. All right, so I guess while we're waiting, let me remind everyone again how this formula pertains to our calculation. Again, the ones on the paper, the S is C, was represented by C rather than S, but it's the same exact thing. You can think of it as this side is what's gaining energy, meaning the water, what's happening to the water will be on this side, because isn't it absorbing the energy coming from the, it's coming from our, what's it called? It's coming from our metal that was heated. The delta T, the initial temperature we've recorded, but the final temperature for both this side and this side will be the same, because the idea again is that whatever it fluctuates to, then that must be the final temperature. It's about 30 seconds into it. Temperature is about 22.6 degrees. So we'll see if it kind of holds steady or if it will keep rising. One thing I should do is to make sure that our sample is actually submerged, because if it's not, then we're not measuring this properly. Based on what I can see, the metal is in there, it's submerged in the water, and I'm going to wait for a few more seconds and we'll call it their second temperature. All right, it looks like another 30 seconds, 22.4. So there's a slight decrease, but what we'll have to watch out for is kind of pay attention if there's fluctuation or if it's going to be consistent. And if it's consistent for a couple of minutes, then we can pause right there. All right, so, sorry, going back to this while we're waiting. The final temperature for both this side and this side will be whatever we call as the final temperature in our reading. The initial was different, right? This side will have initial temperature of the metal, which was 100 degrees. This side will have an initial temperature of our water, and this side will have the water, the one absorbing the energy, and then this side will be the metal, the one that's releasing that energy. Another 30 seconds is 22.4, so that's looking pretty good because that means if it's hold steady for another measurement, I think we can pause it there, or we can stop this first experiment. Now, with regards to the S, the specific heat capacity, these will be two different specific heat capacity. Since this is the side that's for water, then we could use the specific heat capacity of liquid water, which is 4.18 joules, grams per degree Celsius. There's one conversion we need to do. Water is, there's one conversion factor that every 1 milliliter of water, if it's pure water, it's 1 gram. So if I have 150 milliliters, is that 150 grams? It's something that we can use for our conversion. Now on this side, the mass of the metal, we're going to have to measure that once it's done in this experiment. And what's missing of all of these variables, what's missing is this, the S value of that metal. So maybe I'll write underneath kind of like the indication of what's missing and which side is for which. All right, I think we can call it a 22.4 because it's now our third or fourth measurement that kind of stays within that value. So if that's the case, then I could stop this particular experiment for metal A. And I'm gonna get paper towel to dry up our metal. In fact, based on the procedure, they want us to reweigh the whole thing. Oh wait, so actually, based on the procedure, they want us to pick up the metal and dry it and weigh that. So it shouldn't be hot anymore, but just to be safe, let me put it this way. I'm gonna dry that metal. Move this water away from the computer. All right, trying to dry it quick enough for us to try the second experiment. And what I'm going to do is kind of like move this away. Part of this, again, is the mystery of you not knowing what the metal is. And we're just basing on being able to identify it based on our data. So right now, I'm going to zero this. You can hear it like dropping into our scale there. It looks like the weight of sample A is 31.28 grams. 31.28 grams. Okay, again, let me hide our metal. Okay, so now we can try our second experiment. So one thing that I'm going to do is replace our calorimeter with a fresh container. So give me 1 second. So we have a new container, and we need to weigh this. So let's do that real quick. Actually, I think we weighed it with cap earlier. This particular one is 7.61 grams. 7.61 grams. And then the next thing we got to do is to add our, so I've had some water kind of set aside, a different one, 150 milliliters yet again. This is for the second experiment. So I'm going to add that to our calorimeter. We need an insulator again. So a secondary cup. And then measure our initial temperature. Make sure it's touching it. Yep. All right. So while that's measuring the initial temperature, I'll announce it. Keep in mind, this is the second metal that we're testing. I'm currently heating that metal in boiling water so to pick up the starting temperature of 100 degrees. And we have our initial temperature of the water for the second experiment is metal B. The initial temperature of water is 20.2. It's kind of settled at that temperature. And now what I'm going to do declutter our space. Same exact procedure as we did earlier. I'm going to move our metal into this, measure the temperature, and hopefully find a point where it kind of holds still, and that's what we're going to be using. Turn off this fire. So again, 20.2 is the initial temperature of the water. The initial temperature of metal B will be 100 degrees Celsius because it's been sitting there for quite some time. So now metal B, try to kind of hide it from you. All right, let's drop metal B, it's in there. So let's kind of see what the temperature change, you give it some time. Starting to increase, now it's 20.5. I'm going to swirl our calorimeter, or they call it calorimeter bomb, like the official calorimeters. It's usually made of metal, but since again we're kind of improvising, and even in our lab we would have done something similar. We would have used these styrofoam cups, double styrofoam cups. We're now at 20.7 degrees Celsius. So since our setup is like this, you have to consider as part of the error analysis when you're writing the lab report that this is not exactly the most accurate way and precise way of doing this experiment. We're at 20.7 still. This is our metal B. I'm going to give it some time. Let me swirl this again. I also need to check if the thermometer is actually submerged in the water. It is. If it does hold steady for a bit, then we'll use that. Since we're waiting, same reminder. This side will be the calculation for the water. S is specific heat of water. M is the mass of water. It was 150 milliliters of water, which is 150 grams of water. Our initial temperature here was the number I had pointed out earlier. I can't remember what it is now, so I hope you were keeping track when you were watching. Final is whatever we call as the final temperature. This is the missing number that we're trying to identify. The mass of this metal, we're going to test pretty soon. And then the initial temperature was 100. The final is whatever, again, we call. It's looking to me, this is the third time I believe that we're measuring, and it's still 20.7. I'm going to give it one more measurement, and then if that's the case, then that we've collected our final temperature. So it's not looking like there's any fluctuation in temperature. I think we're going to have to call that at 20.7 degrees Celsius as our final temperature. So where does that temperature goes? It will be the final temperature on both sides. So remember, delta T is final minus initial. So final temperature for this and this side will be 20.7 degrees Celsius. Now one last data we need is we need the mass of this metal. So I'm going to remove this. Get a paper towel to dry it up. That was metal A that I dropped. There we go. All right, so here's metal B. Try not to lose it or spill it. Hard to pick it up. Okay, you got it. So I'm trying to dry it right now. And then I'm going to weigh it, and that will be our last data point. Okay, metal B. Based on our measurement, it is 34.02 grams. That's the mass of metal B. So for this set of calculation, where does that go? That would be this mass. And it's already in grams, so there's no need for a conversion factor. All right, that is our lab. Hopefully you've recorded all the data. Start working on the lab report. Same as before, you could either print it out and write directly on it, if you can try to squeeze everything on there, Or the other option is writing directly on your notebook. You don't have to include the procedure or materials. There are some questions that needed to be answered. The data table has to be included, and I don't think there's a graph for this one. Show your calculation, always have units, and always have a conclusion, even if the lab procedure doesn't ask you, or the lab doesn't have a section for it, it always have a conclusion. What's the takeaway, and what are the errors that could have happened for this? The main question really for this is we're trying to figure out what is metal A and which one's metal B based on you calculating the unknown specific heat. Now, once you've done those two calculations, on the handout, there's a table where you can compare and see which one is the closest to that answer. If nothing is close to it, it's possible we have our faulty data, then what is your best guess out of the options that you have there? Okay, that's about it. Have a good day.